I know that one of the first things that pops in your head whenever we talk about the acids and bases is the pH scale. And the reason for this is because, of course, you've been exposed to it in middle school and probably even in elementary school. It is a very important aspect of pH, or excuse me, of acids and bases, and that's because it is basically a measurement of the acidity and basicity of a compound. It's a way to numerically represent it and to compare them all on the same scale. Uh, like it says here, it's based on the logarithmic scale, and what that is basically where everything is a tenfold increase or decrease depending on which way you go. So for example, a pH of 3 to 4 is a tenfold change. So a pH of 3 is 10 times more acidic than a pH of 4, whereas a pH of 4 is 10 times more basic or less acidic than a pH of 3. So if we were going to move 2 points in the pH scale, that is not 20-fold, that is 100-fold. If we moved 3 points on the pH scale, that is a 1,000-fold increase or decrease depending on the way you're going. So that's what it means by the logarithmic scale. Every single number on the pH scale is 10 times more or less a change in the pH, or excuse me, in the H plus concentration. So the part that you know very well is the fact that anything between 0 and 6 is going to be acidic. So this is going to be acids over here. And then anything between 8 and 14 are going to be bases. Then, of course, right here in the dead center, 7 is neutral. This is going to be neither an acid or a base, or to say it better, the H plus concentration and the OH concentration is either not present or it is equal. That makes it neutral. Now, that being the case, anything acidic over here towards close to 6 or 5 is going to be considered a very weak acid. And everything way down here near 0, like 0, 1, and 2, are going to be very strong acids. Likewise, on the right side, if we have anything around 8 or 9, that's going to be a very weak base. And anything closer to 14, like 14, 13, or 12, is going to be considered a very strong base. So as you guys can see, as you get closer to 7, you become a weaker acid or base. And as you go further away, they become stronger, the two extremes being on the either end. So that is a 0 to 14 on the pH scale. Again, 7 being neutral right there in the center. Water is neutral. That's why we could drink it. It's just fine. Although, again, remember that quite a few of the liquids that we do drink are acidic, Coca-Cola and all of our citrus drinks that we all enjoy. What I also want to point out is that we have these two here. We have a pH and a pOH. Basically what that is, again, is a measurement of the H plus concentration, or in this case, a measurement of the OH concentration, the hydroxide. Now, pH and pOH are tied together because if you look right here at neutral, 7 plus 7 gives you 14. 14 plus 0 gives you 14, and 0 plus 14 gives you 14. So basically, like it says here, if we add pH and pOH together, we always get a total of 14. It's just one is a measure of acidity, meaning the pH. One is a measure of the basicity, which is the pOH. But they all, if you add them together, always equal 14. And that's just the way that the pH scale works. It goes from 0 all the way to 14. There is no 15 and there is no negative on the pH scale. It's 0 to 14. All right, thanks again. As you guys all know, well, yeah, that's it.